All right, welcome guys. In this video, we are going to be taking a look at some of the properties of just the basic exponential function. So yesterday we learned a little bit about our standard form, and we know that standard form of these exponential functions is a times b to the x. All right, again, this here is our standard form, but what's really our basic exponential function? Our basic exponential function contains the natural base. All right, it contains the natural base. Maybe you've seen this before, maybe you haven't. It is the number e. All right, so this is some f of x is equal to e to the x. This here is going to be the function that we are exploring today. F of x equals e to the x. So I'm sure that your first question is what is this e? But isn't that just another variable? No, e is a number. So let's take a look here. What exactly is e? E is the number that's known as just the natural base. All right, so if you've heard of natural log before, that's log base e. Log base, the natural base. All right, and don't let this get you confused, okay? Oh my God, e is this number, what's going on here? It's the same exact thing as really what pi is. All right, think about pi. It's just some number, right? We approximate it as 3.14159, blah, blah, blah. All right. E is the same exact thing. E is just some irrational number, meaning that you can't write it as a fraction. Okay, it's an irrational, never-ending number that we approximate as about 2.72. All right, about 2.72. And what's really the reason for this? There's actually a lot of cool properties of E. It's a really useful constant in some wave equations in physics, and it has some really cool properties in calculus as well that you'll learn more about next year. All right, so when you see this E, don't overthink it. Again, it's just a number, very similar to pi. It's just some number that helps us. It's a very useful constant in nature and in mathematics such as physics and calculus. All right, so don't overthink this. All right, so let's start off by thinking about the graph of f of x equals e to the x. For this, when we plug in 0, we know we'll get out 1. So this has a y-intercept of 0, 1. You plug in 1, you get out e. Well, 1, e. We don't know exactly where that is. It's at about 2.7. 1, e. And then this is really just going to be an exponential growth function where we are increasing then very quickly. Let me redraw that line here. Very quickly, we will start to increase. And then to the left side, let's think about what's happening here. Okay, on the left side, we are going to get infinitely close to 0 as my x goes to negative infinity. Let's think about why that is, because this is something that some people can struggle with. Right? Let's think of, all right, what happens if I plug in a really negative number? Let's think about like f of negative 1,000. Well, f of negative 1,000, when I plug in negative 1,000, I get e to the negative 1,000. Well, how can I rewrite that? Let's think about our exponent rules. That's the same exact thing as 1 over e to the 1,000. Well, e to the 1,000 is just going to be some insanely large number. 1 divided by that, it's still going to be positive. It's just going to get very, very close to 0. So no matter how negative my x value goes, this function is going to stay positive. It's just going to get closer and closer and closer to 0 as I go to the left. All right, so we will use that as we describe some limits to talk about the end behavior. All right, so thinking about the properties of this graph. Again, we have f of x equals e to the x. So domain, to start off, do I have any restrictions? Is there any value that I can't plug into an exponent? No, right? You're not going to have any restrictions there. You could do e to the 1 million. You could do e to the negative 1 million. We don't have any restrictions on the domain, so that's going to be negative infinity to infinity. Now for the range, we talked about this just recently. We said it's going to stay positive. We can't go to the negative. We'll never actually touch 0. Even as I go further and further and further to the left, it's going to get infinitely close to 0 without actually touching it. So my range is just all positive numbers. So that doesn't include 0. All right, my intervals of increasing and decreasing. So as I go left to right, in this situation, well, I can see as I go left to right, it's increasing the whole way. It's going up along its entire domain. So it's going to be increasing along the interval negative infinity to infinity. And when is it decreasing? Never, right? As we're going left to right, it is always going up. And because it's increasing the whole way, we're not going to have any extrema. All right, one thing we might make note of is for these intervals of increasing and decreasing, e to the x is exponential growth. If we have exponential decay, well, it's going to be the opposite. It's decreasing the whole way, hence decay. All right, let's continue with some of these properties. So let's talk about our end behavior. I'll do the left end behavior first, and then the right end behavior. So the left end behavior, that's as x goes to negative infinity. Our limit of f of x as x goes to negative infinity. So what value is that going to approach? Well, we said it earlier, it's going to get infinitely close to 0. And then as I go to the right, well, as I go to the right, it's just going to keep on increasing and increasing and increasing. So as I go to the right, it's going up to positive infinity. So now as far as asymptotes, we do not have a vertical one. All right, looking back here, it looks like, oh wow, we're increasing straight up. Well, it looks like it's almost straight up, but it's really not. It's just increasing very quickly. Okay, there are no discontinuities. We're not going to have a vertical asymptote. So for vertical asymptotes, we don't have any. Horizontal now. We can, in this situation, we could say, all right, we do have a horizontal asymptote at y equals 0 because as x goes to negative infinity, we will approach it. However, as x goes to positive infinity, we don't approach that asymptote. So maybe we just want to specify y equals 0 is a horizontal asymptote just as x goes to negative infinity. All right, just specifying that. And then lastly, maybe we want to identify some intercepts here. We already talked about our y-intercepts, right? When you plug in 0, your y-intercept is going to be 1. And then there's no x-intercept because we never touch the x-axis. All right, hope this helped you guys out, and best of luck.